And hello and welcome to the stream. So today will be kind of a little bit struggling with technology, I think, because I did set up a new Linux machine, but I just managed to do that just before the stream, so it's not exactly ready to be like used without issues. Reload. Ah, damn it. Yeah, okay, there are definitely some issues, but that's fine for today, because today anyway I kind of want to have a look at some of the core algorithms that I'm using. And in particular, the one that I really want to look at, and I think that one is in Block Checker, is the one for generating, I keep saying permutations, but it's basically sets of n elements. This one, generic non-recursive find. So what this function will do is basically it will generate all the sets that satisfy a particular constraint, and the constraint is expressed using a function. This works pretty well, except it's a little bit slow and also a little bit complicated. It's a pretty big function, and I kind of realized, thinking about this, is that basically what happens here, it gets a list of elements that we are picking out of, and then it basically just generates results, and I even changed the function that the result is just a single dimensional vector, which kind of makes it even harder to understand. But essentially you can kind of think about it, it will just go through all the possible combination of n elements, or size elements, out of the elements, and it will always just call this function that returns a boolean, and if this function returns true, it will just add it into the result. That's kind of the entire idea. Well, the tricky part here is that the number of elements is actually bounded. So how I use this function is that I'm always picking out of a block, a Sudoku block. But each Sudoku block inherently is limited to the size of the Sudoku, right? So I will never have more than 9 elements in the elements over here for a 9 by 9 Sudoku. So I might as well just use my Sudoku square, which kind of works like a bit set. Like if you were here to or watch the recordings of how I did this, it really is pretty much a bit set with some extra functions that are custom to Sudoku solving. But inherently it's just we use an integer and we just mark bits in that integer for the positions that represent the particular value is still possible in that square. And how we solve the Sudoku is just we remove the possibilities by setting the bits to 0. It really is a bit set. That's what it is. So ultimately I could just generate sets using this data structure. I mean, not using this data structure, but storing the results in this data structure, because let's just go back to this block checker thing, right? So let's just kind of imagine what's happening. So let's say I put in elements, well, if you are getting lost, I can explain anything more deeper. Okay, so if you are new to Right. If you are new to C++, so okay. So let's rewind a little bit, because I mean this is actually interesting stuff, right? So the way numbers are represented in memory is just a set of bits, right? So a number 4 would be 1 0 0. Why? Well, because in binary, I mean, because the last bit represents a 1, this bit represents a 2, and this bit represents a 4. So if I change the 4 to 5, then it would be 1 0 1, right? Now, kind of the trick you can do is, if you want to basically have, let's say we are talking about like a set of elements from, in Sudoku, you know, each square can be 1 to 9, right? And obviously in a solved Sudoku, it's one particular number for every square. But as you are solving it, each of the numbers can be either present in the square or not, right? So what you can kind of do, you can say, okay, like, let's say that the 1 is represented by the 1 bit, you know, so the last bit of the number, if it's 1, it means 1 can be in the number. If it's 0, 0 cannot be in, 1 can be in the square, and 0 means 1 cannot be in the square. So if I kind of have something like this, 1 1 1 0 0 0 1 0 1, right? So this would kind of mean that in this square I can have a 9, I can have an 8, I could have a 7. You know, just so it lines up. I cannot have a 6, I cannot have a 5, I cannot have a 4, I can have a 3, I cannot have a 2, and I can have a 1. So you can kind of compress this state of this is still possible into just bits. And once you do that, you can do very like interesting operations with this, because let's say you want to see what are the numbers that are possible across like 2 squares, right? Because there are some solving techniques that kind of try to find like groups of 2 squares that have the same set of numbers. Well, if you have it represented as the bits, and let's say I have like a second square that's just like this, well, how do I get, you know, the bits that represent both of these together, like all the possible numbers across these two squares? It's just simply a bitwise OR, which is a very fast operation. So, you know, in the bit numbers, it would be, so this one I already have, so this would be 1 1 1 0 0 0 0 1 0, and the bitwise OR would be simply 1 1 1 0 0 0 1 1 1, right? So you can do these operations very quickly, and bitwise, so end is actually a boolean, so that's true or false. So bitwise OR is just OR, bitwise AND is just single AND. There's XOR, and this is a bitwise inversion. Yeah, that should be correct. And they really, you know, just work on top of the bits one by one. I mean, obviously the CPU will just do it as a single operation, but you can kind of think about it like it just goes like through each pair of the bits and computes the result bit by bit. So this was me kind of talking about how I kind of use it to represent the state of the puzzle, where I basically use the bits to represent if a particular number can be present in the puzzle. But what you can also do is, let's say I'm interested in a set of numbers that, like just as an example, that together make 15, right? So I want to find all the sets of numbers between, 1 and 9 without repeating the numbers that together make 15. And let's say I'm only interested in the sets of size 2. So I'm trying to find pairs of numbers that together make 15. Okay, maybe let's make it slightly bigger. So 3 of them, and then make it 21. No, it's a little bit too much. Let's make it 16. Okay. So for 2 it would be very easy because you just, fix one and calculate the remainder. But with 3 it becomes more interesting. So what are the options? So like it would be like, for example, 1. I cannot then pick a 2 because I have 15 remaining, but 15 I can make, for example, with a 6 and a 9, right? So this would be one possibility out of like all the sets. But the interesting part is also this you can also represent as bits, right? You can basically use the same storage system as here, and basically the 169 would turn into 1 at the end, then 0, there's no 2, there's no 3, there's no 4, there's no 5, there's a 6, no 7, no 8, and a 9. So basically this set would be represented with this number. And if you do this, then every result is just one number because it represents the entire set. And actually there are pretty efficient algorithms to actually go through all the numbers that have particular number of bits set. So this is actually what I want to do. I want to take the algorithm that's going through the numbers that have the same number of bits set, instead of having this big recursive function. Because this one is basically just a plain backtracking algorithm that just, makes a path, and if the path doesn't really work out, then it just goes back. If you know basically depth first search, it's kind of the same idea. If it goes into like a, dead end, then it just goes back and then tries some other possibility. Okay, so the algorithm that I looked up is this one. Is basically the next higher number with the same number of bits set. So let's have a look through this one. Okay, so the rightmost bits very rapidly, then leftmost bits. Yes, okay. So the idea is to find the rightmost string of ones and shift the pattern to right extreme except the leftmost bit in the pattern. Okay. Okay, I think I need to look at the example. Right. So we have the X. Okay. So the rightmost string of ones. So this one, sure. Right shifted pattern except leftmost bit. Okay, this I already don't get, so there is to find the rightmost string, shift the pattern to right extreme. Ah, okay, the leftmost bit out of this pattern, okay. So for C versus C++, generally it's easier to write a C compiler, so you will still find more like weird hardware supporting C and not supporting C++, so that's one reason why you would use C over C++. But generally, if you can, I wouldn't really pick C over C++. C is less expressive than C++, so you kind of need to write more code to do the same thing, and it's missing a lot of the like niceties that C++ just gives you straight up. I did work a lot in C because the project was just in C, but you can actually mix them together pretty easily also. But there isn't inherently like something that you straight up cannot do. Yeah. I mean, so the C++ standard actually includes most of the C standard, so kind of C can be seen as a subset of C++. You can kind of write like code that's valid C in C++. There are some slight differences basically where the language was modified very slightly to kind of work with C++, but you can kind of see still, you know, C being the subset of C++. Okay, Osmos bit. Okay. I don't have enough people to do mods yet, but maybe at some point. Yeah, you know, in some very distant future when I actually have a lot of viewers, I might do mods. Right, okay, so this seems pretty neat. So we pick the rightmost pattern, then we ignore the leftmost bit of the rightmost pattern, shift it to the extreme, so basically pick up these, yeah. Then we take this, shift it once, then we can take everything that's preceding the pattern, and because it's a pattern of zeros, we know that there's some patterns of ones. We know there's some zero in between inherently. So we know that we kind of have the space to then do this OR over here. And okay, this is a very interesting algorithm. A very simple one. Okay, I think they even, yeah, they do have a code. Rightmost set bit. Oh, I don't like this. Wasn't there, I think C++20 has some bitwise operations. Yeah, see you soon, hopefully. And you know, have a nice progress on your job. Okay, bit. There was oops. There was something new in C++20 for sure. Or maybe it was even C++17. Where would it be? Okay, let's just search for C++20 bit operations. Oh, there's a header bit. Yes, okay. Yeah, so it's C++ 20. Okay. Oh, there's even a hash single bit. Cool. This would be useful. Yeah, C++ 20. I'm trying to actually switch over to C++ 20. Now the question is if these things are actually implemented, because I know that the compilers are kind of catching up still to C++ 20, so but on this machine I have GCC 10.1.1, so that should be a very fresh version of GCC. Find the smallest, find the large, okay. Bitwise rate. And pop count. Okay. So the pop count and hash single bit is definitely something that's useful for me. Unfortunately, well, I get the bit ceiling could be what I'm looking for. Find the smallest integral power of 2 not less than the given value. No, that's not exactly... I mean, why is that bad? Like, it's great that we have new stuff, no? I mean, the old C++ before C++ 11 was horrible. I mean, it was still better than other stuff, but like, it was pretty bad. Find the largest integral power not greater than the given value. Okay, so this should find... Yes, okay, so this should give me the most significant bit, I think. Okay, let's just test this. I think this is... Oh man, you can never learn C++ completely. Like, that's not possible. Like, you can keep trying, but I don't think it's possible for a single person to understand all of C++. And yeah, don't buy C++ books, come on, like, we are in a digital world now. Like, just going on CPP reference, do they even have... I think there was... let's see. Was there a way? No, unfortunately there's no good way to like look up what C++ 20... Oh yeah, there is. Okay, here. So if you go to CPP reference, they have the versions of C++ up here. And if you click on them, it gives you the list of new things. So you can straight up just go through this. And that's already like a very good start. And I mean, like, if you actually need to use all of this stuff, I would be super surprised and I would ask you what the heck you are working on, because that's crazy. Like, there's like a bunch of like different threading things and whatnot, so, you know, you will probably use just like part of this. Okay, let's just make a small directory here and let's just try stuff, because I want to see how these things work. And the best way to do that is to just try things. And I think I should make it slightly larger, right? It's not big enough. Let's make it 32. Oh, I need to restart my terminal. That's annoying. Okay. Is this big enough? Yeah, okay, let me know if it's readable enough. I'm not quite sure. Okay, so we want a bit header. So, and I guess let's just grab IOStream to just print things out. And let's just try things. So if I do, and now it went away. Where was the? Okay, bit 4. So bit 4 of, sure, let's do bit 4 of 9. I mean, he said he doesn't consider himself an expert on C++. He said that, so you know. And as far as like the C++ standard goes, like you have different committees that work pretty independently, so I don't really, I expect there are people that have like a very deep understanding of parts of C++. I expect people that like write compilers to understand C++ overall pretty well. But yeah, like there's just like, if you just watch like CPPCon or some of the videos from these conferences, like it's so clear that even the experts that are sitting on the committees are missing a lot of stuff, because, you know, people from the audience will chime in and just like correct things. But I mean, that's normal, like, you know, like this is computer science. You need to be comfortable with not knowing anything basically all the time, because there's always like another layer of complexity that you can always just go deeper and deeper and deeper. Right. What the heck was I doing? Okay, I want to print the bits. How the heck do I format a number as bits? Print out bits cout. Thanks for the follow. Oh, I make it a bit set. Oh, is that really the only way to do it? That's a bit weird, but sure. Oops. Bit set. I mean, okay, 16 is good enough. Okay, let's see if this actually compiles. Oh, what the heck? I don't have G++ installed. I only have GCC. How did it happen? What the heck? Okay, that's a bit... No such... What the... What? What's wrong with my GCC? Yeah, as I said, like, this will be partly me trying to figure out what the hell is wrong with my PC. Because this, like, I just finished installing this. This is Linux. This is specifically OpenSUSE, the Tumbleweed distro, which is like the latest software. What the heck? Oh, is it GCC C++? Ah, yes, okay. Okay, that's what it's... Why is it named such... Whatever. Whatever. Let's not think about these things. Okay. Right. std C++ 2a, is it? I do have... Oh, I don't have bit set. Right, okay. Okay, oops. Okay, let me just move things around so you can see it properly. I just realized the bottom was getting cut off. Okay. Yeah, okay, that's better. Right. No matching function. Okay, I think it needs an unsigned. Oops, what happened there? Ah, okay, stuff is working. Perfect, okay. Oh, cool. Yeah, so this is Tumbleweed, so this is like the 42 point something. They have like the weird naming schema. Okay, so for 9 it returned, this is 1, 2, 4, 8. Okay, so this, yeah, so this actually does return the most significant bit. That's cool. Okay. So then I guess let's go back to the algorithm. What was it? So right most set bits. Wait, why is it looking for? It should be the rightmost string, not the right. What? Okay. Yeah, so I don't think GCC, like this version of GCC is even like properly released yet. So this is again GCC version 10.1.1, and I think the official release GCC version yeah, 10.1 released in May 9th. So this is like the bleeding edge subversion of the current version. Where the heck is it? It just returned. Oh, stable. Oh no, so 10.2 is actually stable 7 days ago. Okay, so it's not completely bleeding edge then, I guess. Yeah, okay, so yeah. But yeah, if you want C++ 20, you kind of need to use GCC 10, I think. Otherwise, you don't really get the current features. Yeah, like you can see the lot of C++ 20 stuff happening. Probably based on Ubuntu though, right? Okay, so x plus right one, next higher one bit. Ah, okay. So this is, yeah, they basically take that and add a 1 to it, so it becomes like 1 bit over. Okay. But there was find the smallest integral power not less than the given value. No, that's not useful. Oh, we could use the counter 0, I think. Consecutive 0 bits starting from the least significant bit. Yes. Yeah, okay. So basically to get the rightmost set bit, we can do okay, let's try this. So what was it again? Counter 0, right? Okay, counter 0 for the 9U, and we basically want to shift 1 this many times. So this should return the rightmost bit, I think. No. Okay, yeah, because I'm not doing the... Yeah, that's correct, but I'm just not printing the correct stuff to figure it out. Okay, so bit set 16 and just do 9U to have the baseline. Right, okay, so the 9U is, 1001. Then the the rightmost bit is this. And this is the rightmost bit, okay. That's a very good question. I actually don't know, because again, this is a fresh installation, so I didn't really set anything. Yeah, yeah, I don't even have a Vim RC thing, so I think it's just getting recolored because of my terminal. But yeah, I need to set all this stuff. Okay, so that gets us the least significant bit. So we add the least significant bit next higher 1 bit. Okay, so next higher 1 bit is part D of the above explanation. Okay, let's go here. Yes, okay, so this is just we add 1 to the pattern and it shifts the highest bit up. Okay, makes sense. So yes, we want to do that. So then this was bit set 16. So it's a 9U plus this thing. Okay. Yes, okay, I'm missing 1 extra bracket. Okay, yes, so this is now shifted by 1. Good. Then isolate the pattern. Right one's pattern. Okay. What the heck? This is such a weird algorithm. Okay, so we isolate the consecutive bits, and I think I will need like a better number to just play with bits. So let's just do this quickly. So uint 16 16t, right. So what is the number they're using over here? They're using 156. Okay, sure, that works. So let's just pass in that number. So we have a little bit more bits to play with. Okay. So again, isolate right one's patterns. Okay, so this will be, I need to start storing this stuff. Uint 16t shifted, let's call this shifted. So this is the with the one shifted. Okay. Then the isolated bits will be uint 16t. So shifted num sort shifted, yes. Okay. And let's have a look at how that looks. Right. Well, but it doesn't. Interesting. But this now has the extra one here. No, I don't think this is correct actually. See you later. Okay, so what the heck does this one actually do? Rightmost set bit. Okay, well, let's just try and see what this does, because I'm actually not quite sure. So, okay. Right, 16, right one, right. So let's just print this and print this. Okay. Ah, yes, because I don't have X, I have num. So I mean, okay, so this one does indeed just isolate the one bit. So I was correct, but then this is really not following the description of the algorithm, because then this XOR over here okay, I'm making mistake here. Num shifted. No, this is correct. Wait a second. What? Next higher one bit. Strange. Okay, well, let's just see if this works anyway, but this really doesn't follow the description. I guess, okay, isolated equals, well, right one, shifted. Oh, No, this is actually the one shifted by counter 0. Okay. Oh, I didn't print it. Let's print it. Okay. I mean, it is correctly shifted. But again, this is a bit weird because it doesn't really follow the description. Yeah, we shifted by 2. So, okay, so I mean, this will basically... Yeah, so this will actually correct it to the value it should be, because... but the thing is, in the description they actually just shifted it by 1. Yeah, interesting. Yeah, it's part A of the above explanation. Yeah, so it's kind of weird because they kind of add the 1 here and then shift it by like twice, which doesn't just remove the one here, but it removes 2 of them. It's a curious thing to do, but I mean it works. And then next, higher 1 bit and write 1's pattern. Okay, so then I want to do next higher 1 is which one? Next higher 1 is my shifted, right? So, right, okay, so let's just make this a new number. Next will be shifted or isolated. Right, okay, so let's have a look at what this looks like. Bit set 16. Next. So I don't even need the bit floor, actually. Interesting. Okay, so that does seem to actually work. Right, so... I want to do one more test. So, okay, let's just move this over here. Right, so the num is input, I don't need the couts. Okay, so this I really need to document. So get the rightmost bit. Rightmost 1 bit, right. Oh, and add it to the number, right. So this XOR gives us what exactly? Okay, so this will give us the next 1 bit that needs to be set. Okay. So this XOR So this will basically keep the stuff that changed, which is like the new. Yeah, so get the changed bits. So this is all the ones that inverted into zeros, and the new one that basically got added on the left side. So all the consecutive ones that flipped to zeros, and the new left one. Okay. So then we do this thing, which will basically shift it right. So shift the pattern to the right. And discarding the two leftmost bits. Right, and then yeah, this part I still don't quite get why this works. And then I get this pattern and either just do a bitwise OR, and it works, which is so weird. Like, why does this line up? I don't get it. Ah. Okay, I'm starting to see it. So the reason why we are discarding these is because, so one of them is this new one that we added here. But when does, like, where does the second one go? Yeah, because we still are trying to basically maintain the same number of bits. Okay, let's just play with stuff. So let's just start with 111 in binary. Or is it B? How do you write binary numbers? I always forget. What the hell? No, that's not. Come on. 0B. Okay, so 0B111 is the thing I want, right? And then while, okay, let's just go up to a specific number. So while num is less than sure. Next num, and just print it. Or I guess we should first print it and then do the increase, right? It's at 16 num. Right. Okay, let's get rid of all this crap. We need to have a return in our main. Okay, so let's build it. That's right. Okay. So I mean, yes, this is working perfectly. Okay, I really need to understand this step. So I mean, here we are discarding two ones. One of them we need to discard. Ah, okay, I get it. So we are discarding two of them because the first one, yeah, okay, so this already has like one extra, so that's one of the bits we are discarding. Because these are all the changed bits, so it's all the ones that were there previously plus the new one. So we have, in the isolated, we already have one extra. And so we are getting rid of the one extra, but don't forget that the shifted already has the edit bit. This is where we are adding the one extra bit. So that's the second bit that we need to remove. Okay, so that's why it works. Okay. Yeah. And okay, and this belongs here. So discarding the two leftmost bits, we discard two bits because isolated has all the changed bits, which already is one extra, and shifted already has the new left bit added, which is the second one. Okay, cool. Yeah, and then we just do the OR, bitwise OR. Okay, so basically, if I just keep calling next, I will keep getting, and if I kind of think about this as a set, where the ones represent the presence of a bit. What's happening here? Ah. Okay, give me a second. Right, so if I think about this from the perspective that this is a set where the ones represent the presence of numbers, if I just want to go over all the sets, I can just keep calling the next, right? And the only thing I need to make sure is that like I don't overflow my leftmost bit, and I kind of know what's the ceiling, because yeah, I pretty much actually want to do something like where the heck is it? Find the largest integer power. Yes, okay, so I kind of want the bit floor, yes. So I kind of want to do bit floor num. Bit floor num is lower or equal to 1 shifted by the by the max, right? Okay, so if so let's say the maximum is 9, so that's we have numbers from 1 to 9, so that this would be basically max minus 1, right? Okay. Oh, not replace, come on. Okay, so while basically while the highest bit of the number is lower or equal than the highest bit that we can represent, which is, you know, if you take the max minus 1 and shift the 1, that's basically the position of the thing. So, you know, for if this was a 1, then basically the highest number that we can represent is 0b1, right? If this was a 2, then the highest number, like the highest bit that we can represent is this, and so on. So that's basically what this part does, and then the bit floor is just grabbing the highest bit. Okay, so if I do this, so this basically would give me the all the sets of 3 numbers. Okay, let's see what happens here. And I screwed up my, oh yeah. Okay. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, perfect. Yeah, so this is basically looping over. If I have like sets of 3 elements from 1 to 9, this is exactly representing that, like looping over all the possibilities of those. Perfect. Okay, so this is much better than the crazy function that I currently have. Unfortunately, it requires C++20, but I mean, I can live with that. I guess the only question would be, it could technically screw up WebAssembly, so I still need to verify that. So can I do C++20 with WebAssembly? Okay, so how do I do that? Right, I do have the Sudoku UI over here. Okay. If I just go here, there was yes, the standard. Let's just do standard 2A. And let's see. Yes, I need to grab. I need to grab the repos again for WebAssembly. Basically, this ASM. No, this one. The SDK. Yeah, okay, this one. Right. How the heck did I grab this? From where? mscript and SDK. mscript and website documentation. Right. Oops. No, this is the wrong window. This one. Okay. But not here. Okay. So now we have mscript then. And then I want to do install latest. Not here, here. Okay, and I guess then just activate latest. Oh, right, I need to... Sure. Okay, let's just quickly restart the session. So now we should have the mscript and yes, we have the mscript and commands, which is great. Okay, so now back to the Sudoku UI repo build mcmake, was it? Oh yeah, perfect. Permission denied. Oh shoot. Okay, what's oh, this is a bit weird. Wait, did I maybe skip a step or something? Okay, let's just do CMake first. Interesting. Yeah, sorry about this technological issues, but as I said, a very fresh install of Linux on a new machine that I just built. So yeah, a bunch of stuff is not working yet. Right. Okay, so it's wait, it doesn't like this the CSX standard. So I guess do like 20 then? Okay, so this is fine. Okay, there's some weirdness happening. No. Okay, let's try it again. I think I did this wrong. I think it. Yeah. Okay. So now it seems to be correct. And now I just do make. I think. It's okay. So this seems to be compiling with C++20 fine. But to be fair, there's no C++20 code in here, so let's just grab our new okay. Alright. Actually don't really need it. So let's just grab this piece of code that I just wrote. And I guess let's just stuff it somewhere so it gets compiled. Okay. Where would I put it? I guess I can just put... Well, I cannot put it into the main. I could put it into the Sudoku UI, this thing. Okay, I guess. And let's just call it somewhere. Like, I mean, I can just return next 0u, something like that. That technically shouldn't do anything, but yeah, okay, let's see. So I just want to see if this compiles fine with all the bells and whistles of C++20. Okay, I mean, that looks correct, so I guess we are fine as far as C++20 goes. So good. Okay, so how the heck do I do this? Right. We have okay. source square. So I have this thing. I should make it a little bit more generic. So I can use this data structure for both sets and Sudoku squares. So I mean, okay, I actually need to remind myself because I did kind of write this by hand. The standard bit set. The standard bit set. What does it actually offer? It has the logic operators. It has input output. Oh, this is not very useful. Okay, so yeah, we have the bitwise operators. Then what does it do? It has a bunch of constructors. Sure. Set value at a position, reset position, flip at the position, sure. I mean this, yeah, it wouldn't really help me too much by just switching to this. It's kind of, I can, but it's kind of pointless. Okay, so how do I do this? So I really kind of want to have the base value thing. So that one really should just have anything that's just related to the data, and shouldn't have like specific things like, I don't know, is possible, count possible, value, because those are specific to the Sudoku square. Right, so I guess what I kind of want is just plus, minus, bitwise or bitwise and. Yeah, so the idea is plus is but plus and or is basically the same thing, right? Do I actually have a plus? I don't remember. I have an and, I have an assignment, I have plus equals, okay. Minus equals, yes, minus, yeah. I have all of these, equals. Wait a second. Oh, I don't have a bitwise or. That's where the confusion is coming from. Yeah, so I just went for the plus, I didn't do the bitwise or. Yeah, okay, but I guess I can just edit. It doesn't really change anything as such. Alright, I guess to be completely clean, I should just have minus bitwise or bitwise and equals and assignment, right? I need those for sure. Count of set bits, I definitely want that. There was the C++20 operation. So pop count counts the number of 1 bits, okay, and then has single bit is if it has, yeah, that's basically the same thing. So has single bit So that for, I guess, for the Sudoku square, that will be just like is set, right? I guess I can use the bit seal to get the value. Oh, actually, bit width is that. Yeah, that actually does that more explicitly, right? Because for 1 it returns a 1 if the bit has a position 2, or I mean, I guess basically however we count, right? Like either I count this as position 0 or 1, but then basically this returns a 2, and then if I have a bit at the third position. Yeah, okay, so the bit width actually gives me explicitly the thing. So bit width is the value. Okay, what else? Can I use other of these? I don't really need the rotations. Yeah, okay. Or I guess I could also use the count. Yeah, okay, so it's either the bit width or the count 0. Yeah, okay, I guess the count 0 is actually the more appropriate thing to do, because the bit width would be kind of misusing it for something that's not really intended, right? Get the number, and I guess in this case it returns the number -1. Yeah. Okay, so we basically, I will create a new data structure for this, just offering these operations, and then the square and the set will be basically adding extra operations on top of that, right? Okay, cool. So that's stuff to do in a minute, and I think I really need a break because I've been streaming for almost an hour and a half, and I need to refresh my water, grab a small snack, and I will be right back in a couple of minutes. Okay, and I'm back. And what's wrong with my music? Oh, it's just very quiet. Okay. Right. So as I said, kind of need to create a new class that will represent just the basic data structure, and then to build the Sudoku square and the set on top of that. Okay. But one thing I really feel I should do is just to create a core directory over here. So this will really be just like the CMake, CMake this, right. So the core directory will just be the core algorithms, because right now they are kind of sprinkled over the place, and I kind of want to centralize them a little bit, because yeah, right now it's not amazing. So right. How do you add subdirectories? Oh, it's just add subdirectory source, right? So then I guess what I want is to create a CMake list over here and just do, oh no, actually the other way around. So in this CMake lists I want to do add subdirectory core. Yeah, basically what I want to do is just like create a core library. I guess I will need this. Oops. And there will be just add library. No, they call it. Let's just call it simply core, and that's it. Sure. Let's just call the data structure that we'll use for the bits just a bit set. I mean, it is what it is inherently, so it's fine. Okay. So now the question is, can I figure out how to yeah, basically now I have a problem because I have my C line running locally, and I have the remote Linux machine that has the up-to-date GCC. And the tricky part is I can set it as a remote toolchain, and technically that should work. But I don't think it did actually work. Okay, let's just try this. New window, yes. So if I go into settings and toolchains, set this thing to be my top toolchain. Maybe it will work. Okay, so maybe this will actually work. But I think it was failing with my Sudoku setup. Maybe I just need to get rid of this thing. So now if I just stop, okay, so the two chains are okay. Now let's see what happens. Yeah, okay, there are some issues, unfortunately. But weirdly enough, if I do the same thing over here, I think it worked, right? Yeah, this is a thing I will need to figure out, because I need to use the machine as a remote development. And I mean, worst case, I will just switch to Visual Studio Code, because I know that one can do it for sure. Oh, yeah, okay, so now it's complaining that the file doesn't exist, which fair enough, it doesn't. So let's just quickly go and fix that. Let's just touch bit set cpp and bit set.h. Okay, they can be empty, that's perfectly fine. Okay, CMake again. Come on. Here I need to have iOS forward. Okay. But this definitely works then. Okay, so what's the problem over here? What is it actually complaining about? Reload. Incorrect clank is not the one detected by CMake. I mean, I do have clank as well, but why would you want to have clank? This is pretty strange. Okay. Is this actually compiling on this machine? Okay, it is. So wait a second, what actually failed here? I mean, I don't really see errors. Succeeded. Don't really see what the problem is. Yeah, okay, I think for now I will need to figure out this offline, I think, because I'm not quite sure what the problem is. The remote build should just work, but I mean, it's not super important for now. I guess let's just work in Vim for now. It doesn't really change my workflow too much. Okay, so what I wanted to do, let's just copy the the square.h into bitset.h and square.cpp into bitset.cpp. All right. So, oops. So, within namespace Sudoku, I want to have a bitset okay. And now I will struggle with the formatting, of course, because there always has to be something. Right, we don't really want the default constructor. So indeed this goes away. Yeah, I definitely want the default copy and move constructors, because that's fine. I mean, technically I could have a default constructor. It's not, yeah, it's a question of what exactly semantics I want to have will be. Yeah. Okay, so the explicit constructor is still okay, so this one actually changes based on if this is a set or okay, so let's just make this also default, right? It's set no accept default. Yeah, okay, so let's just make this all default. And I guess the same for assignment operator. Right, indeed. So bit set default assignment operators. So I guess we should talk about the state that we have. Let's just right. So we just want to have the one 64-bit int, which should just be data, and I guess this one just should be initialized to 0. Okay. Right, okay, let's do comparison operators. So lower than, higher than, does that make sense? We could do that. There's the new C++ 20 this operator. Unfortunately, it will not really find it, right? So if I go here, freeway comparison, okay. I guess I can make this work. So operator okay. How exactly does this work? Ah. Yeah, okay, so this isn't the worst idea. Sure, I can do this. Yeah, basically I can use auto, so I don't have to think about the result. Return, so okay, data then equals right hand side data. Okay, and yes, okay, this is again no accept. And I guess it doesn't really make sense to run this if you discard the result, so this should be also no discard. Is it no discard? I think it is no discard. Yeah, no discard. Okay. So we have assignment, we have comparisons. What else? Yeah, okay, so all these operators now. And I guess I need to write the documentation for this. Right, three-way comparison operator. Values are sorted lexicographically. So I guess well, I guess it's kind of inverted lexicographically, because if I have like okay, I think I need to make this explicit. So so 111 will be, yeah, so yeah, okay, so this is just sorted by ordered by value. Which means that 0B001 will be less than 0B111, which will be less than 0B1000. Okay. And right. Right hand side of the comparison, and return well, since I'm returning auto, I actually still don't know what the heck this is supposed to return. Oh, okay. So we can actually make it default even. Oh. Ooh, that's very good. Okay, yeah, definitely. Definitely. So please, no discard, cost expert, auto operator, bloop, const bit set, hunt height side, no accept. Const equals default. Okay, I'm being a little bit too verbose, but okay. This should work, and yeah, we'll see if it explodes or not. Right, so we have the comparison. So now the actual operator. So as I said, I want the minus, or, and equals comparison have count of set bits has single bit and grab a single value out of it, I guess. Singular value, something like that. Maybe that should actually live inside of the yeah, so I guess this should be protected, and yeah, this should really only expose the base operations, and then basically square should inherit from this. So it's not really like actual like there's no, it's basically a mixin, right? Like there's nothing objective oriented here happening. But yes, actually that is what should be happening. Right, so let's just quickly do these. So this will all be no, well, there will be no discard. I guess for all of them, right? Not for the equals mix. Yeah, so not like these doesn't have to be no discard, these three, but the rest should be no discard. So let's do it. Const expert auto operator minus oh, okay, I don't have to do that. But actually, yes, let's make it a friend. So this will be an inline friend definition. So this will return a bit set as a value. And it will have 2 bit sets. Okay. So this I already have somewhere over here, right? But it is a little bit awkward. So I can do it slightly better. Right. Okay. I guess I should have an explicit constructor from the value, right? So that one, let's just put it here. And maybe this one actually should be protected as well, maybe. I'm not 100% sure, but let's just make it protected for now, and then we can revisit that idea later. So this will be explicit const expr bit set from an uint 64 value no except, and this will just do data equals the value. So param value, the value to set this bit set to. Okay. So right, so basically this should then be return bit set of LHS underscore data and the inversion of RHS data. Right. Then similarly for all the other operations, so right, so bitsetwise OR is just bitsetwise OR, there's nothing special about that, so that kind of represents a union. Then no discard bitset operator and so this is exactly the same idea. So bit set LHS data and RHS data. Okay. Now just the documentation for this. So set minus operation param LHS is left hand side of the operator, RHS is right hand side, and return the set minus result result of the set minus operation. Yeah, okay. Okay, and the same for these two. So this is set intersection operation set intersection set union operation. Right, okay, so we have the minus, we have the union and the intersection, and now we need the variants that are assignment of these, and then we also need the same stuff but with getting a specific bit on the other side. So right. So these don't necessarily have to be no discard, but this will actually return this bit set in particular. So operator minus equals. But there are still no except. Or I guess I should mark these no except as well. Okay, so this will simply be data minus equals RHS data. Well, not like that, like this. And equals, okay, like that. And return this. Okay, was there anything special I was doing over here though? No. Okay, good. So let's just continue. Yeah, I guess I can just copy these because these are exactly the same, it's just different set minus operation minus active operator result of the minus operation, indeed. So the same thing we want twice more. So we want the union. So it will be twice or. And like that. And set intersection operation. Okay, and intersection is simply an AND. Okay, so now we need the variance for the single bit. But I wonder, I could also make it that I wonder what is more clean, because what I'm considering is, so either I make these operations where basically I'm doing, you know, operator something, and then I have here like an unsigned number, or I could just do bit set static method, just returns a bit set called single bit unsigned number, and yeah, this is again static const expr no accept, and definitely no discard. And this will just return bit set of, I guess I should have an assert here that the number is less than equals 64. So this will just be 1 shifted by number -1. Right, okay, so actually, yeah, number needs to be at least 1 and can be higher than 64. Only that way this operation makes sense. Okay. So how are we actually doing it? Single bit. How did I do it over here? It's this craziness. Okay. Yeah, I think I will need to copy that because I remember having issues with this. Yeah, so return bit set of this. Okay, so this way basically, since this returns a bit set, this makes operations like, I don't know, bit set, oops, so let's say I have like a bit set of 10, A, and then I can do A minus equals bit set single bit, I don't know, 4 for example. Yeah, I think this is cleaner than the previous way I did it. So let's stick with this one then. So construct a single bit set, and the ordinal number of the bit to be set, right, is the param number, and return bit set with a single bit set. Okay. Okay, this is all correct. Am I still missing stuff? Oh yeah, I wanted the number of bits operation and the single bit value basically, right? So const expr, right, number of bits, so this should return unsigned. Number of bits, something like that actually. It's const no accept. You should not call it unless you actually use the value. I get this should be first. Okay. And the operation I wanted to use for that was pop count. Yes, pop count. Return pop count. I guess std pop count of data. and no discard const expr unsigned singular value. So this one I actually kind of want to make return nonsense if it's not being called correctly, because the problem is I don't really want to add like extra checks into calling this. Alright, so control 0 of data plus 1. So okay, this one is return number of bits set. Okay, and this one, if a single bit is set, returns the ordinal value of the ordinal position of the bit. Return ordinal position of the bit, right? Undefined if more than one bit is set. I mean, it's not really undefined, but I guess unspecified, whatever. Simply said, it returns nonsense. Yes, okay. Anything else that I wanted to add? I think that's actually it. Okay, now I really want to write the tests for this. So I have to supply count bits, has single bit. Oh, has single bit because there's a special function for that. Okay. So check whether only a single bit is set, right? Returns true if only a single bit is set. Yeah, and there, I mean, I could just call the count set, but since there is a special function for this, I will just use it. Const expr bool what do I call it? Is singleton. Okay. Accept. I guess has singleton value, right? Because that's kind of makes it pairs up with the singleton value. So if has singleton value, then I will just call singleton value to get the value. Otherwise, singleton value doesn't make sense. Right, and the function to do that is has single bit. So return, oops, std has single bit data. Perfect. So that should be good enough for now. Right, okay, so this is actually the copy of the square data structure, so this should all go away for now. Okay, and And okay, so if I just try to build it, everything explodes, of course, right? Because in the CPP file, yeah, okay, I have the serialized, deserialized nonsense over here. For now, this should be empty. Okay, good. So we have the call library, but I definitely want to do some tests for this. So there was definitely a thing for const expert testing that I removed. So let's try to look this up again. Shoot, I don't... Where did it... Oh, this one. Okay, good. So, test... okay, so const expert test... Static require, right, okay. Const expert tests. Oh, interesting. Okay, well, let's try that, I guess. Yeah, because it basically reuses the test twice. So, in the CMake lists, so const expert tests, const expert test, project options, project warning, catch main. And I want to build against the core library. However, I'm actually not quite sure whether this will work. Okay, let's see. So now I need the const expert tests CPP, right, which is very simple. Let's just stick to my naming scheme. Alright, so let's just include core slash bit set. I mean, this can remain here for now. Okay, let's just see if this works, but I need to rename this. And this. Okay. So here's the second argument just after the target name. Okay. Right. So wait a second, how am I including the square test? Ah, okay, by actually hard coding the path, which sure I can live with that. So this would be okay, bunch of issues. Okay, sure. Oh geez, right. So this doesn't like no except. Why would it not like no except? No except. Okay, let's just open a second terminal. Right. So what was the first line it complained about? It was line 22. Okay, so it kind of doesn't like the const with the no except, so maybe this needs to be the other way around, no except. Okay, let's see if that was it. Oh, interesting, so that actually seems to have been the problem. Right, but then it doesn't like the no discard. Attribute ignored. Okay. No discard. Interesting. But why would this be ignored? That doesn't really make sense to me, but maybe this needs to be the first thing on the line. Okay, let's go back to this. So this is struct, no discard. Yeah, maybe it needs to be the first thing on the before the static even. Okay. Did that help? Yes, I think it did. Right, okay, so I guess it needs to just straight up needs to be the first thing. Oh yeah, and then I have a bunch of typos, I already see them. Cool. Okay, let's fix that. That's pretty easy to fix. So, these... Right, let's just take the no discard. This needs to be first. Okay. Then, okay, this is the typos over here that I made. Okay, the same idea because I just copy pasted this stuff around. Cool. Wait a second. Oh yeah, no, that's correct. Did I make? Yeah, these are all no discard. Cool. Okay. Right, build. Okay. Interesting. So this, huh? I thought this just straight up. What the heck? Why is it not? So okay, pop count. Oh, this returns int. Okay. Why does it return an int? That's, I mean, it returns the count. Why would it return an int? That's a bit strange to me. But, I mean, okay, I will just not question that. To not lose my sanity, for example. Okay, so then I just need to static cast these two unsigned. Static cast unsigned. Because obviously this will not return a negative number, that would be crazy. The same thing here, static cast unsigned. And yeah, okay, then just add another one to it. Let's just double check. This one. Yup. Okay, cool. So let's go back to the building. Cool, okay, now it builds. So now let's actually try to write some tests with that. So static require that bit set of... Okay, I cannot really... Okay, I can do this kind of stuff. So if bit set single bit, sure, let's do 8 dot oh, I've already forgotten what I called the functions. So singleton value should return an 8. Where is my code? Over here, yeah. So singleton value should return an 8 over here, because that's what the single bit does. Okay, let's just try it with that. Bit set has not been declared. Okay, well, yes, okay, because it's in a namespace. So yes, you are technically correct, which is the static assertion failed, where you are not super descriptive about what actually failed. Well, this is poop. Why doesn't it really say anything? And I mean, I also kind of thought that... Is it just the ordering of things? Because, so in here, CMake this... I have this entire section. But the problem is it doesn't even get to this. So I guess if I put it the other way around, maybe that will help. No, it's still failing on this particular thing. Okay, but I do have relaxed. No, but these are the old ones, right? Ah. That's annoying. How do I make it this build before that? Okay, let's just try to get rid of this and do CMake again. Maybe that will fix it. It's kind of weird, like I would kind of expect it to follow the ordering of blocks in the CMake list. Like I wouldn't really but I don't think it's doing that. This is literally the first thing it builds. Can I just do make relaxed const expert tests? Ah, I can. Okay, perfect. So then I can just run this. Ah, okay. That's okay. What the heck is happening? Now here. Okay, so singleton value. Count zeros. Count zeros from... Ah, of course, because I'm a complete moron as usual. I want to count the zeros from the right, not from the left. Okay. Well, that explains things. Make... Yeah, okay, now it's fine. So, oops. Just a normal make. Perfect, now the const expert tests are passing. Okay, so I guess now I just need to write a bunch of simple tests to just exercise all the methods. Right, so I need to go into the test directory, const expert tests, and let's just open this. It set h, right. I should really install some plugins that will show me just the outline in Vim if I'm going to be stuck in Vim for a while. Although I really sincerely hope I won't, because it's kind of annoying. Okay, so we kind of tested the single bit, static require Sudoku bit set single bit dot has single value should be true for sure, and the count should be 1, right? Static require Sudoku bit set single bit count set should be 1 because we only have 1 bit set. Right, okay, so now let's prepare some values. So 2 variables, so I want to let's just set them to something specific. Okay, so what kind of test we want? So let's do something like this, minus this, then okay, like this, union with this, then intersection, so intersection could be 0, 1, 1 intersecting with 1, 0, 0, and no, 1, 1, 0, and what else? Yeah, I guess I need to test the assignment operator. Yes, the comparison operator. What else? Count set singleton value has singleton. That's kind of it. Okay. So let's just set this up. So this will be Sudoku bit set single bit 1 and static require. Okay, so this need to be const x for now, and that should all work. A dot count set should still be 1. Oopsie daisy. So it should still be true, and the singleton value should be 1. Okay, so let's just test this. If this works, it should work. Okay, I didn't have to close it because I have the make file over here. Yes, obvious errors as usual. Screw it, I should just do namespace Sudoku. To just make it easier on myself. I mean, assuming this will not break catch, but I think for example in gtest it's okay to have the test in a namespace. So that should be fine. Right, okay. Error passing const Sudoku bit set as this argument discard qualifiers. As this argument discards qualifiers. interesting. So I guess I should make it That's very interesting actually. I wonder, is it because I'm returning a non-const thing out of an assignment? I think with const expert this should still work, but I could be wrong. But I guess let's just quickly see and try. So I want to change the assignment operator. So source core bit set. So over here, let's make this const. And let's see what that does. Yeah, no, he doesn't like that. Okay, I could try it the other way around. So I could make this a non-reference, which would actually make more sense, to be brutally honest. But I suspect it will also not like this. Yeah, it doesn't match the expected declaration. Indeed, it doesn't. Okay, so this could straight up be that I cannot do this kind of shorthand and I need to do this. Oh, okay. Yeah, okay. That's actually interesting. Oh, hey, how did I... What the heck? Are my, like, alarms not working? I totally missed the chat message. How did it happen? That's weird. Sorry about that. Welcome back to the stream, if you are still around. I kind of expect... So if I make a const expr function over here, right? That just returns a bit set and call it like a setup bit set. Sure, let's just call it setup bit set, right? So bit set a equals bit set a single bit. Oh, come on. A bit set a single bit to return a. So if I do this kind of thing, because the function is const expr, this should work, but I'm not sure. It's not a typo. Indeed, typos happen. Okay. Okay, now, but now, oh, but yes, I said, like, now it's working fine. That's so strange. I guess if I just put it into the main, it doesn't really have the context to know that it's supposed to be const expr, right? Because yes, if I literally just like grab this and copy paste it over here, it straight up doesn't work. Even though if I make this const expr, can I do this? Is that something? Yeah, I actually haven't played with const expr enough to know this stuff. Yeah, no, it doesn't like that. Okay, let's quickly check const expr. I'm sure there's a way to do that. There's the const expr if statement, const expr yeah, so this is declaration. Yeah. So yes, like I can have const expr functions and those will be evaluated during compilation, but I cannot have like a const expr scope, I guess. Even though, I mean, that would actually be very neat to have something like that, but I guess that's not on the menu. So sure, let's just use this kind of shorthand. Well, I already have it here, so don't have to duplicate the code. Right. So now I expect these to be two singleton value is nonsensical. All right. Okay, but actually what I want is add the third bit as well. Okay, so now this has the 3 bits, so it's basically equivalent to this thing over here. Well, should I just write a function that translates? Yeah, okay, I will just do this. Unsigned value and ST. Well, okay. For actually not unsigned value, what I want is unsigned int 64-bit. So for 0 up to 64, if value and I one shifted, yes, this craziness. Well, yeah, okay. So one shifted by I. Yes, that's correct. So shifted this many times, and this needs to be in brackets. So if this is not 0, then this bit set a equals bit set single bit I done. Okay, this should still work, and then I can just do this over here. Static cast uint 64t. Oh, there's actually it was like an oh damn it, there's like literal damn it, literal type 6040 format macros draw. Right. Yeah, I'm basically trying to figure out how to write 64-bit retrievers without going through a bunch of hoops, but I think I just need to use this macro. And I guess that actually should land in source core bit set, because oh, I already have that, right, because I actually do that in a bunch of places. So I can actually do it over here. So uint 64c 1 shifted by this and it, so uint 64c, oops, and I don't have to do this static cast for most of the stuff. Was that the only place where I did that? Maybe it was. Okay. So then over here, the same idea. So this one, shifting the I doesn't equal 0. Bit set single bit, and over here, right? Why do I keep closing this file? I don't know. And bunch of typos as usual. Unsigned. Okay. Call to non-constants per function. Oh, jeez. Well, this is just amazing. Like, why the heck is... Why is assert not const x per... Oh, I guess because it does like an abort or something, right? What am I doing? Let's just close this. Well, that is quite annoying, but I guess I need to sacrifice the assert then, and just kind of realize that I don't do stupid things. Okay, right, operand is greater Oh, what am I doing? No, that shouldn't be 64. Damn it. Where did the... No, it should be an answer. What? Static cast of the number. So this looks like an underflow. Somehow number is 0. Bit set. Oh, because am I calling it with 0? I could be single bit. Oh yes, indeed. That's my mistake. +1, indeed. Yes, that was a mistake. But that's what tests are for. Okay, static assertion failed. Yes, because now the count is not 2 for sure. That's definitely correct. Okay, so now the count should be 3. Okay, so now I can continue. So I want another one. Cost per bit set B is setup bit set uint 64C 0B010. Okay, perfect. And now the fun part. So I want, well, first of all, let's just quickly check this value. So b.count set is 2, no, 1 actually. Static require b has singleton value actually should be true. Okay, and I guess I can check whether the singleton value is actually correct. So static require, oopsie, b dot singleton value should be in this case 2. And now I want to see these things. So static require a minus b should be setup bit set uint 64C 0B101. Okay, so that should be definitely true. So let's see if that works. Not really. Okay, static assertion failed. So the counts are all over the place somehow. Okay, what the heck is happening here? So let's just run make relaxed context test. I need to rebuild this and just run it. Count set what the heck? Why is count set 64? That doesn't really make sense. And it's happening on the A. Wait, is my setup function incorrect somehow? Ah. Yes, it's the bitwise operations, stupid priority again. That's always an annoying problem, and I always forget about it. Yeah, now it's working. Cool. Okay, so we know this is working. Then static require okay, actually let's do it this way. So now we have a 101. Okay, then I can check if C or B, we are back to A. And I guess I should also check. Well, yeah, okay, that's fine. And okay, intersection. So for that, I think I need to make new ones. So const x per bit set d will be setup bit set unit 64c 0b 011. And another one, const x per bit set e setup bit set uint 64c 0b 110. Okay. Let's just quickly check whether these have same values. So both of them should have count set and not have singleton values. Oopsie daisy, what am I doing? E, DD, and this doesn't. Oh. Right. Where is that coming from? I actually really don't know what I pressed there, but okay. Okay, so both of them should be count set 2, and then if I do intersection, x per bit set f is d and e, then I'm back to this thing exactly. So count is 1, has singleton value, and the value is 2. Right. So I do still want to check the comparisons, so right. So f should be less than a. Static require. So should c be less than a? But E should be more than D, and E should be more than F, and F should be more than, no, D should be more than F actually, yes. Ooh, okay. And I keep closing this file for no reason. Okay. Yes, again, we have the stupid priority of operators. Where am I doing that? Over no, what? Over here, right. Okay. Chained comparisons are not supported inside assertions. Wrap the expression inside parentheses or decompose it. Right. I think it just needs this thing to be like that. Am I right? Yes, okay. Everything is working. Perfect. So our crazy bit set is now ready and everything is const expert, which is great. So now what I want to do is basically migrate the square to use the bit set. So okay. So this will inherit from the bit set. Include from core bit set. Okay. Okay. So now we need to kind of rewrite these functions using the bit set. So if right. I didn't write a function for this thing in particular, I think. So core bit set. I don't think I have a function that basically checks if a particular bit is set. Yeah, okay, but that sounds like a useful thing. Check whether the given bit is set. Returns true if set, false otherwise. Right. Okay, so no discard. Const expert bool is value set unsigned. No, not value. What do we call it? Is bit set, right? Bit const no accept. So this is simply return data and a single bit dot data. Okay. Okay. So if we intersect with the single bit, that should be it. Okay, so then in the square, what I can do instead of this, return bit set is bit set number. So no discard. Well, okay. Actually, I can get rid of this because is possible becomes kind of pointless then. The same for count possible, because now I have a count that just does that. Is set. Okay, so this one should actually return bit set. It was this has singleton. What did I call it? Has singleton value, right? Has singleton value. Okay. Value. Well, okay. So that also makes it pointless then. So this just gets away. Value. Okay, so there's a here I have a little bit of more logic than I have in the thing. So the singleton value just returns just straight up returns the number of rightmost zeros. But oh, I can actually make it work. So, right. So the thing is, what I actually, the behavior that I want is that if everything is 0, yeah, okay, no. Well, if everything is 0, it should also return 0. Which I can actually achieve by doing this. I don't really want to do modulo here. That's kind of annoying. Okay, I will just do the logic here for now. I will need to think about if I want to actually move it inside of the bit set. Maybe I do. So if it doesn't have a singleton value, then just return 0. Otherwise, return singleton value. All right. Okay. Okay, so this rate's finally starting to be interesting. So here we have some custom code. So next. Okay. So it basically returns the next bit that's possible. Right. Is bit set I, return I. Okay. Yeah, that's fine. Reset. Okay. Yeah, okay, so that's fine because these are all custom. reset changed, has changed. Okay, that's perfectly fine. Has intersection. Okay. Would this make sense? Yeah, probably yes. Okay, let's do it. So no discard. Cost expert bool has intersection. Const no accept. I kind of feel like there should be just like one qualifier that's just like, I don't know, like a plain function or something, or just because basically like all of these, like no discard, const expert, no accept, it like feels like this should be one thing. Right, so if it has an intersection but with another bit set, right? So const bit set runtime side, so I return data and runtime side data. Okay. Oopsie daisy. Actions better. There is an intersection with the given right hand, or with the given bit set. Okay. And now these things need a slight adjustment. So right hand side, the bit set to check intersection with true if the bit sets intersect on at least one bit, false otherwise. Cool. And the formatting is all over the place, but I will need to fix that later. So this can go away. Has extra possibilities. Right. I mean, this is a little bit special, but I kind of feel I should have it on the bit set as well. Has additional bits or something like that. Const Is this check actually correct? I'm just looking at it and I'm not sure, because if I have extra bits, no, okay, yeah, it is correct. Because if all the bits that are in data are contained within our data, then if I do the bitwise AND, yes, then I will basically remain with data which will be the same as data. Yeah, okay. No, but if shoot, okay. No, I don't think it's correct. Okay, so let's just quickly jump to this. So let's look at the possibilities, right? So if I have 1 1 1 and okay, so if I have this kind of situation, 0 1 1 and 1 1 1, then this returns the correct thing. If I have something that's not intersecting at all, right, then this also returns the correct thing. But what if I have like a 0b 1 1 0 and 0b 0 0 0 1 1? So now the end will be 0b 0 1 0. Oh no, but that's correct. But okay, so if I had this situation, then the end will be this. And it doesn't have... okay, now it's correct. I don't know why I got confused for a bit there. But sure. Has additional bits, bit set RHS const, no accept. Return data and right hand side data isn't data. Okay. But this bit set contains bits not contained, yeah, within the given bit set. Okay, that's a horrible sentence, but I guess it is what it is. To check against, return true if, oh come on, if this bit set only, no, true if this bit set contains bits not oh my god, within the given bit set, false otherwise. Wow, that's like the sentence of the day. And what the heck did I just do? I don't want this window. Okay, as extra possibilities can go away. This can go away for sure. This as well, 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 this as well. Wait, no, these not yet. So these are the... okay, I think I deleted more stuff than I should have. Okay. So the ones that intersect with a square, I want to delete. Right, square, square, square. Right, but this one that actually works on top of a number, I want to keep. Add number as a possibility. Number. Okay, this is the square. This can go away. This is again on top of a square. That can go away. number. Okay, this can go away. This is again square. Okay, then we are in debug stuff. Cool. Right, this single bit thing needs to go away. Data needs to go away, but origin and max I want to keep. Right, so okay, I need more tests because I added the has intersection and has additional bits and also is bit set. Right, so let's do that. Okay, this should be named differently. So bit set tests and tag it with bit set. Indeed. Okay. So what do I want to test? So I want to test if for example E and immediately I have forgotten everything as usual. So what was the is bit set, right? E is bit set. So second bit should be set and first bit shouldn't be set on E. So static require not E is bit set 1. So that should be correct, and then the has additional bits. Okay, so static require so C right. So F should have only one bit set, right? So if I do F dot has additional bits with, for example, E, that should be false. And static require if I do for example F and C, not F, E and C. So E has additional bits with C, that should be true. And static require so F and C should not have any intersection, so F dot has intersection with C should be false, and static require E should have an intersection with C. Okay, let's see if that is all correct. Oh geez, okay. What's exploding? What the heck? Did I not include the correct thing? Well, okay, let's just see if these things are actually working. So this test is fine. Make const export tests. Okay, so these tests are okay. It's just the Sudoku square that's exploding. Okay, and that's kind of expected, actually. Okay, so square dot h, right. So what's the problem over here? Okay, so this shouldn't be data, this should actually be bit set. The same. Well, that's fine. But I'm not 100% sure what's actually the problem over here. So expected class name, but bit set should be a class name. That's curious. Core bit set. Yeah, it's in the Sudoku. Ah, damn it. It's always stupid stuff like this. Always. Well, okay, let's just call it Sudoku bit set and not screw up the naming scheme. Okay, okay. That should fix it. I mean, not exactly, because there will be other errors, but that should fix this one particular specific part. Okay, so now it doesn't like the pop count. Wait a second, what? That's a bit weird. I mean, if this wasn't there, then how the heck did it compile before? That's so weird. Okay, I don't need assert, I want stdint, I don't want string, definitely not vector not. How did these even get here? Okay. Does not have any field name org. Okay, that's... There's something broken in the Sudoku class, in the square class, because it definitely should have those. Ah, okay, yeah, there's like one extra bracket over here. Okay, cannot convert bit set to yes, which is right. Okay, this one needs slight work to fix it. Square. Okay. Where was that? Single bit, right. Oh, come on. Oh shoot, how do I do this? I mean, I could make... I could make a protected function that basically does this. I think that's kind of the most sensible thing to do. You basically have a protected function that's like single bit value or something to that effect, and then just use it here, like, okay, something like that. Single bit value. Okay, so that would be source core bit set, oops, bit set at h. So over here, next to the explicit constructor, I want to have generate a value with a single bit set. Param number the bit to the ordinal of the bit to be set, right? Return value with a single bit set. So this will be uint 64t, and it will be definitely no discard const expr single bit value unsigned number const no accept. Oh geez, this is almost like writing Java. It's like such verbosity, it's kind of ridiculous. And maybe some of these are redundant, I actually don't know. I would have to check. But I don't think I could not const expr no accept. I don't think they are like redundant against each other. And no discard is definitely completely orthogonal to everything, so... Right, so this is very simple, so this will be basically the thing I use in the single bit value. Where the heck is it? Right. So actually what I want to do is single bit value number over here, and this thing I want to move to over here. So this will be just return of this. Okay. Right. So now okay. We are making progress. Cannot call member function const expr without object. Yes, okay, this should definitely be static, which means that const doesn't make any sense. No match for operator uint 64 and Sudoku bit set. Right, I need to change these things around. So Okay, let's open this in the other tab, because this will be more than one instance of this thing. Okay, so this should be single bit value, single bit value, single bit value again, and that's it. Oh, right, I should definitely have an inversion operator on the bit set. That makes total sense. I haven't really used that before, but being able to invert a set is quite useful. But okay, let's just get this into like a compiling state, because I have been streaming for almost 4 hours, and that's usually the time it makes sense to stop. Right, okay, so we don't have a member is possible, so this is coming from where exactly? 145. No? Oh, in the sudoku.h, okay. Sudoku.h 145. Yes, we don't have a is possible, we have is something. What the heck was the method called? Core bit set. Is possible is bit set, right? Is bit set. Okay. Then line 248. What? Use of deleted function operator equals. Why would it be deleted? That's strange. Okay. It's implicitly declared because declares a move constructor or move assignment operator. I probably do, but okay, let's oh no, what am I doing? This is the wrong thing. Not Sudoku. Square. And not this. Okay. This is the correct thing to look at, but where the hell is the... Oh, move constructor. Okay. That was a bit strange that it got in there, but sure. Okay, is set. We don't have is set anymore. We have, and where is this coming from? Sudoku. Yeah, okay. So this thing, source sudoku.cpp line 174. So is set is not a thing anymore. It is has singleton value. Yes, has singleton value. Yeah, so much more shorter and clean. Okay, we had more of these, right? Oh yeah, there was the is possible on line 376. 376 is bit set. Then count possible on line 533. Okay, 533. Count possible was would I change it to count set? Okay, count set, and there was one more. 556. 556. Right. Count set. Okay. Build again. Okay, more of them. Right. This is coming from square. Square, right, on. Okay, is possible, so is bit set and is bit set. Okay. Okay, bunch of other stuff. So now we are in block checker. Okay. Is bit is set. Okay, sure. Has singleton value. Has singleton value. Has singleton value. Okay. Is possible. Is right. Is possible. So this is bit set now. Is bit set. Is bit set. Is bit set. Okay, then I already see the has intersection. Has intersection. So this was has in so has intersection is still has intersection. So wait a second, why is that complaining exactly? That should not be complaining. Has extra possibilities. Oh, because this one I renamed, right? Because this one has additional bits now. Okay. Then I have make. No match for operator square and square. Yes, okay. Because yeah, I just need to re-export these functions in my square. So shoot. Right, I will need to basically re-export all the operators, which is annoying as heck. Damn it, is there some way to avoid doing this? Yeah, I will kind of need to re-export all the operators, unfortunately, because I have the extra state that I need to check around. Yeah, and because the problem is, because I don't have all of the state in the bottom class, which it would work in that case straight up as it is, but because I have extra state in the square, whenever there's an operator that basically returns the bit set, that doesn't really work with the square, of course, because then I'm missing the extra state. So I have options. I could basically modify this, basically use curiously recurring pattern and basically have these return maybe that's actually the solution. Yeah, if I use a curious recurring pattern and have these methods actually return the type of the parent, that would work. It would make testing this class in particles super hard, but that's actually something I don't care that much about. I mean, it's important for me to know that it works. And I guess I could just test it with like an empty shell. Okay. No, that's the thing to do. But I don't think I have time to do that today. I don't think so. But it's actually very nice to do for the next time, because I haven't done curiously recording pattern in ages. Yes, okay. Let's do that next time. Which kind of means I cannot really update this code as it is, because right now it's completely broken. But I'm quite happy with the progress I made today, even though there isn't much to show for it. Yeah, we basically have the two sets. I will have the set and the square, those will be different, and then basically on the set I will just have a next method that will return the next one. I already have the algorithm for that tested, which is just generating the next numbers with the same number of bits. That way I can then just get rid of the non-recursive find, and instead I can just keep calling next, and instead of this like function recursively calling my callback, well, not recursively, basically calling my callback to figure out if this set is interesting, I can just call next, and in that scope check if the value is interesting, and then just, if it isn't, then just go to the next one, which is much more cleaner. I basically have no vectors around, it's just like a single value that just keeps updating, which is so much better. It might not be faster, but it will definitely be so much cleaner. That will be great. And yeah, that's really, like, for the killer Sudoku, it's definitely required. And since C++20 is now seems to be working fine, I will just C++20ify all the code. Yeah, I think that's the way to go. And that's actually, like, that will take a while. I'm realizing, like, I kind of need to put the killer Sudokus on the back burner for a bit, and just doing this C++20 transformation. I need to figure out how to connect my CLion or Visual Studio Code to the remote machine, so I don't have to do this basically, or figure out how to set up my Vim correctly. That's also a potential. But yes, okay. Well, thanks for watching. This has been a weird stream. I didn't really do much, actually. I just moved a lot of code around. But yeah, things are progressing slowly towards some weird goal somewhere that I'm still not sure what that actually is. So yeah, thanks for watching, and again, every weekend, the same time, 2:30 p.m, that's when I stream, and I do intend to continue streaming for the foreseeable future, so join me sometime again. See you!